Greetings, this is Graham Warren working with you on an introduction to AnyLogic modeling. So let's have a look at the canvas. There's the project panel here. There's a palette panel here. Then there's the basic canvas where we're going to be building the model. There's a toolbar up here. And then there's the properties panel on this side. So I'm going to work with you on a model of a serial or tandem queuing network that has got two stations in tandem. Basically we can analyze this as a Jackson network, and we're going to be interested in figuring out the waiting time in system at each of the two customers at each of the two servers, two queues, as well as in total. In other words, interested in the expected flow time of a customer through the system. So when we start with a model like this, you'll do create model on the initial page of AnyLogic. And when you do that, you get an option to name your model, which in this case, I've decided if I click on this Jackson serial network on the projects panel, you can see that I have the option of changing the name here. I'm also getting to select the units, which in this case is minutes. You can change that at any time. We're going to now go into the palette panel, and I'm going to be looking in particular at the process modeling library. So the first order of business is to generate some customers, and they are going to be generated using the source block here. You can go ahead and change these things. I'm going to just say customer arrival, and then I'm going to make this 10 per hour because that is what the Jackson network calls for. Change the units here to hours. And I think that is all we need here. So let that go. Now these flow and they wait in a queue, in a line. And so that is going to be modeled using this queue here. I'm going to stretch it out a little bit because I want to put some timers in here so you can measure things. And then from there, we're going to have a delay. Okay, so this is Q1. Just going to change the names here so that we are clear about things like which queue it is. I think I'm going to just force a statistics collection while about it. Let's check that box. And then for delay, this is a delay that is exponentially distributed. So let's change this. It's exponential. Now, the parameterization of these distributions in AnyLogic is a little tricky. For the exponential distribution, it's the rate, the parameter lambda. So the processing rate at the first queue is 20 per hour. So I'm going to just put that in. And then it's comma 0, because actually I want to make that 20.0 comma 0, just to make sure that it's a float. And that is going to be in hours again. And the capacity of that processor is one customer. So again, the parameter of that distribution is the rate at which processing takes place, 20 per hour. I'm going to force statistics collection there also. Now, from here, it goes into the second queue and processing, and then out. So let's put that in. There's the second queue and the second delay. Just make sure we got that correctly named. So this is, well, I guess I messed that up. Let's try that again. This should be delay 1 here. So I have to make this delay 2 first. And this one has exponential processing with at rate 30. And that is again per hour. And I want to force statistics collection here also. So let's make it a uppercase D. Force statistics collection. This is going to be Q2. Force statistics collection. And then this one wants to be delay 1, right? Confirm that the delay there is exponentially distributed with the parameter 20. Okay, and then so the idea here is we're going to connect these. I want to move it. Just undo that. I want to connect them, so I just double click on that and I connect them appropriately. So there's these ports, and you need to get this these ports connected properly. And then so the idea is that we're going to generate customers. They're going to go through Q1 and with its associated delay, then through Q2 with its associated delay, and then into a sink to be destroyed. So let's put that in here. And we can just make this something like exit. Okay, I want to connect that also. Now, what I also want to do is I want to add some timers. I'm going to put just 2 timers in. These timers are appear down here in the palette in the process modeling library. It is, let's try that again. It's lost them now. Time measure start. Okay, so we're going to put 1 in here. And then I'm going to put a corresponding one at the end. What I want to do there is I want to measure the time from when customers arrive to the network to the time they depart. So to get these to sync up, I need to go into this one and make sure that it's connected to that other one. Okay, so that's how, this is the start of the stopwatch, this is the end of the stopwatch. And let's just change these names just so that so timer 1, and this is going to be timer 2. Timer 1 end, I guess. Let's do it that way. Has to be a different name. So I'll just say timer 1 start. And then I'm going to put another timer in. So we'll do another one here. So call that 1. Timer 2 start. And I want to just capture the waiting time in the system of Q1 with that timer. Could do this for Q2 as well, but I want to reduce the clutter, and this should be enough. So put that in. So this is then timer 2 end. And importantly, we need to connect that to timer 2 start. Okay. So I think we're good. All right, now, so this one is going to measure the time between these 2 timers, and timer 1 and start and end, of course, connect. I think it makes sense to try and run this to see if there are any errors. So there's this debugging process and not doing too much in the model. Once you've got the basics down, makes sense. So let's just see if this is going to execute. So it's looking good so far. I didn't get any error codes, and except it's running the wrong one. Let me just make sure it's running the right model here. I want to run the Jackson serial network. Okay, so let's just see if I get an error on this one. Okay, seems like it's running. Now I'm going to go and change the number of customers that can be generated. Because there's a limitation in the free version of 50,000. So I'm going to have a limited number of arrivals here. Just make that 1 less than the allowed amount, 49,999. I also want to put in some statistics. So let's go ahead and do that. So that's going to be in the analysis part of the palette. And I want to put in a couple statistics here for each of these queues. So just bring these statistics icons in, and then I'll set them up. So I think the first one that I want is I want to know the utilization at this first delay. So we're going to call this utilization Q1. It's a continuous variable, continuous over time. In other words, it's time dependent. And what I want there is I want delay one dot utilization. Now, this function utilization is built into AnyLogic, and you kind of have to do a little work with the help or the user guide to know that it exists. But we'll try that. And then this one is going to do the same for us for the second delay. So this is the utilization of Q2. I really should say delay two, because it's not the Q, it's the delay that we're getting the that's the server that we're measuring the utilization of. So this is delay two dot utilization. And then I also want to know the size of this queue. So let's do that. So this is LQ. Q1, it's also continuous, and this one is going to be Q1 dot size. So there's this built-in function size, and it's going to get the average size of the queue, I hope. Okay, and then finally this one is LQ size, let's see, Q2 continuous to E in there, but size, we should be good. Finally, I want to get the histograms for the waiting time between the timers. So we're going to bring two histograms in here. The first one is going to be the flow time on the system. And I'm going to get the mean, and I'm just going to call this flow time system. That's just the title of the graph. And then what I'm looking for there is timer 1, and now that spelling needs to be exact here, and then dot distribution. Okay, so hopefully that's going to come off. And then I also want W sub S for Q1. You get the mean. Well, let's W sub S for Q sub 1. So this is the flow. This is the waiting time in the system for Q1. So it's going to be timer 2 and dot distribution. I hope I've got it. So now I think we've got most of what we need. Let's give this a whirl. See what we get. Okay, so this is normal. When you build something like this, there's going to be a debugging process almost surely. And so I'm going to say proceed, and I'm going to get my errors. So you'll see some errors. Okay, so this one here is a familiar error, but I'm just trying to remember what caused it. So let me have a look here and just see if I can see what it may be. Timer. Okay, so I've misspelt the timer. Okay, that's the issue. It's unforgiving with regard to that. So we can fix that fairly quickly. So this was, it was timer one end, and then this one here is timer two end. Okay, let's see if this works. Still got a problem. Completely normal. And we'll see what we have here. So its utilization is undefined for the delay. Okay. So I'm going to just I'm going to delete those two. We can get utilizations at a later time. But that's not working right now. In the interest of getting this model working, let's see if we can build it. Okay, so now it looks to be setting up without errors. We know from our work with queuing models that the flow time, the expected flow time of customers in the system is 9 minutes. I believe the breakout is 6 minutes at the first queue and 3 minutes at the second queue. So let's go ahead and just ramp this up slowly. You can see the number of customers. This is the number of customers that have been initiated. In other words, created, and then these are the number of customers that have exited. What I'm getting here is the mean queue length at this queue and also at Q2. And then this is the average flow time at work in the system overall. And I'm expecting that to be about 9 minutes, not exactly because, we're simulating here and there's random numbers being generated, but in the long run, that should play out to about 9. And then I said that at the first workstation, the expected waiting time is 6 minutes. At the second workstation, it's 3 minutes. That's how we get the 9 minutes in total. So I'm going to just crank this up because we have 50,000 customers that can run through, and taking our averages over a larger customer base just makes sense. And so finally, I'm going to accelerate all the way through here and see what I get as an estimate. See, I'm at 49,999, and it's hard to get the queue lengths here, but you can see I was expecting 9 minutes and I'm getting 898 and I'm getting 599. So these results are entirely consistent with the expectations. Hope you enjoyed this clip.